All right, new day and another laptop that needs to be saved, and this time we have a Alienware M15R3. This one was actually taken to a different repair shop to get the thermal paste replaced, but when he got it back, the laptop no longer turned on. The repair shop didn't know what happened to it, and he has some important data on here, so I haven't taken a look at this yet. Let's take a look together and see if we can save this customer's data. All right, the first thing I want to do is see if it turns on. And it shouldn't, because that's what he said. Pushing the power button, nothing happens. Let's plug in the charger. Keep an eye on the power meter here. Looks like it goes up to 0.01. Now when I press the power button, it just goes up to 0.03. That's not good. Let me unplug it. Let me plug it back in again. I want to see if it starts over the same cycle again. What should actually happen on this machine is when we plug it in, it should sit right around 0.02, and then when we press the power button, it actually should jump up to about 1 amp, 1.5 amps, and start moving around. The light should come on, but nothing's happening like that. It just goes to 0.03. Kind of a strange issue. So let's open the bottom and take a look inside. All right, and the bottom is off. Take a quick look around. Looks like we have the main battery here. It's a Dell OEM. We have 2 NVMEs populated. The fans look perfectly clean. This laptop looks almost brand new. This is gonna be like a 2020 model, so it's about 5 years old. It's in great condition. I wanna start out by just unplugging the battery. Let's try just doing a CMOS reset. I'm gonna hold down the power button. All right, now let's plug the charger back in again and see if it does anything different. All right, 0.01, press the power button again, and it just goes up to that 0.03. Now, so at this point, this is kind of a strange one. I'm not 100% sure what could cause this, except some sort of issue with the EC chip. Now, there is a tendency on this model, if you don't know what you're doing, damaging this board-to-board connector, that might be one of the symptoms or one of the scenarios. Let me remove his SSDs. I also want to try a charged battery. I don't know if this battery's charged or not. Actually, let me just plug it in and we can just measure to see how much voltage we have. All right, so here's the battery connector. I want to see how much voltage we have in the battery. And looks like it's showing 0.3 volts. So either the battery's completely dead or the board's telling the battery to shut off. Let me grab a test battery that's charged up, plug it in. There's a chance that it's just part of the power management system where the battery can't charge, the laptop's dead, and it will power off a battery. So let me grab a battery. All right, I got a test battery here, and this should have a charge on it. So I plugged in the battery, and then we can measure. Still the same voltage, actually. So with my test battery, it's still saying it's 0.2, 0.3, right around there. Let me plug in the charger. Okay, it's sitting at 0.01 again, and let me press the power. 0.03, okay, same scenario. This is starting to look pretty bad. Now the customer did mention that the repair shop said that there was a stripped screw somewhere and they had to drill it out. I don't know if that could have caused the issue, if the drill jumped and kind of ripped the board or ripped a trace or something like that. Let me get this further taken apart so we can take a look around, because we may be able to identify some sort of physical damage on something. Okay, let's take a quick look around now that I have it a little more opened up to see if we see any physical damage anywhere. Now, what? Okay, so the repair shop lied. So everyone lies, apparently. So this customer said that the repair shop had a stripped screw and that they drilled it out. That's the end of their story. They didn't say that they soldered on the board. They replaced some components on the board. It looks to me like they ripped something off of here. So these 2 diodes have been soldered on. There's obvious signs of solder here. Let's pull off this board-to-board connector and see if we can see if there's an issue behind this. This is ridiculous. Okay, so this board-to-board connector has a bunch of tiny pins that connect the daughter board to the main board. And a lot of times it gets damaged, but this actually looks okay. I don't see any of the pins bent. So I think we're okay there. Now, I don't know what happened here, but I do suspect we're gonna have some issues, because this ties over to the EC chip, which is over here. And this EC chip could be damaged if the machine's not coming on it with the battery. So, because what this power management does is it actually controls all these input MOSFETs for the charging of the battery and for the DC jack to power the laptop. So let me plug in the charger. I want to measure some voltage in this area. I want to see, now that we've actually identified some physical damage that had been repaired, quote unquote. Let's see what measurements we're getting. So right here on this pin, we should get 20 volts. We are. This one should be 5 volts. We're not getting that. We got 0.9. This one's nothing. And then down here, we should get 3.7. We're not getting that either. Power management chip's probably blown, but this is just crazy. Let me zoom in a little bit. I can't believe that the repair shop would have broken this and then said, I don't know what's wrong. Nothing happened. Let me grab a donor board so we can take a look and see exactly what this area is supposed to look like. So here's a donor board. Should be the same model, same setup. And if we look at what it's supposed to look like over here, we have the two diodes, resistor, capacitor. This pad's not populated. So everything looks good here. So the main thing we have to deal with is figure out if these are blown and if that's blown. And then on the other side of the board, we may have a blown component too. So I'm gonna go ahead and finish pulling out this motherboard all the way because we need to look at the other side. And then also when we're soldering, we just need to remove the board in order for us not to damage anything else with heat. All right, let's look at the other side of that area, which was right here. We'll flip it over, and I just wanna see if we have anything else burnt on the other side of the board. All right, good news. I don't see anything burnt on this side of the board. We're just gonna take a quick look around though. Since there was one damaged area, there's probably another damaged area. And I didn't see where that screw was that was stripped out. Maybe it was on the heatsink. What's this? Okay, that is an area on the heatsink that looks like there was, I mean, it's missing a screw. There's supposed to be one there and supposed to be one there, but maybe that was a strip screw. But I don't see anything else so far, any other damage. Okay, so far, I do think that we do have an issue over here. I can see the issue right here, plain as day. So let's start out by, oh, I don't know. Let's measure these diodes to see if they are actually measuring properly. And they are measuring properly. I think I want to replace this chip first to start out because we're not getting our 5 volts on our VDD line right here, which is what powers up the chips on the board to start up all the power supplies. Starting that will be first, and then we'll do, I'll straighten these up at the same time. Hopefully that would get it fixed up. Now it's a 9241H. It's a 9241H, and I do have some brand new 9241Hs. All right, let's heat up the area. This is a thick board, so I kind of want to preheat it a little bit. I do have a connector over here I got to be careful with. So we're going to be blowing the air away from it, like across this way. But I first want to heat the board up enough, and then we'll get some flux on there. All right, now that the board's a little bit hot, now we can come in here and take this off of here. Huh. Well, that thing just flew away. It's funny, one of the diodes just flew away. And that one's about to fly off of there too. I'll replace those in a second. Oh, the other one just flew away. I'm gonna grab a donor board and I'll just replace them with new ones anyway. Usually the surface tension will hold it. All right, I got that prepared. Let's see, do we need to do anything here? Just put a little bit of flux on there. Let me grab our new power management chip. And we do need to prep this chip because it is brand new. So we need to put some fresh solder on here, tin the pads. Tinning these pads on a new chip will help it receive the solder a lot better whenever it's trying to solder onto the board itself. If you would just do it dry, then you may not have enough solder on both surfaces. All right, there we go. So now we just need to line it up with pin 1 on here. Pin 1's located on the board there. I can't really see what's going on this chip, so let me heat it up a little bit. And then we can reveal pin 1. There we go. Let's see which way's pin 1. And there's our pin 1 dot right there. Okay, so now let me heat up the board again. We'll get this soldered on and then we can go back and replace those two. So I like to just tack this on, move away, tack it on there. I don't really care which direction it is, but as long as you tack it on there, the solder will hold it with surface tension. We'll add a little bit more flux, get it underneath the chip. And then we'll just tap it. All right, got a little bit of solder coming out from underneath, which is perfect. And clean up those edges. Okay, let me get the area cleaned up a little bit, and then we can install those other two diodes in order to get that working and see if we've made any progress. So let me grab a donor board so we can transfer over some of these diodes. Okay, here we go. Yeah, I could have even taken this power management chip off this donor board, but I had brand new ones. All right, so we're just going to transfer over these two diodes one by one. Okay, the first one's installed. Let's do the next one. Now that I just tacked them on there, we want to straighten them up. And I don't focus on getting them straight until later. Kind of want to get them on the board, and the solder will actually hold it in place. There we go. Looks good to go. And everything looks good. So now we'll just clean up the area, and then we can test. Okay, so that looks a million times better already, right? New diodes, we have the new power management chip. Let me plug in our DC jack. Let me go ahead and install the board back in here. Now, I'm not completely confident that this will actually resolve the issue, but it is the right place to start because we were not getting that 5-volt VDD. And that's usually a sign, especially since we did have some damage in that area. The next plan of action would be definitely to change that out. And I think that if this doesn't work, then we're probably going to be pointing towards an EC chip issue of some sort. All right, I do want to monitor the voltage on the power management chip when I plug in the charger. So really what we want is on the second pin, we want 20 volts on this one, 5 volts here, and 3.7 here. That's what we're looking for. All right, so if we measure this first pin, we have our 20 volts. We measure the second pin, we got 0.8 again, just like before, and then we got 0 here. So did not change at all. The symptoms did not change. Now that could mean that we have something else going on, obviously. If I measure, let me measure this while I plug in the charger. Let me unplug the charger, plug it in. It's not even going up for a second. Ooh, we have an issue. So power management chip did not change anything. I just want to press the power button and see if we're still going up to 0.03. And 0.02 is 0.03. All right, same setup. All right, we need to check for a short. That's what we need to do because I replaced those two things preemptively, or those three things, I guess, because of what I saw in that area. But let's just make sure we don't have some sort of short somewhere on the board. So we're going to be in continuity mode and just measure around quickly. Main power rail, that's fine. There's actually not that much to measure on this side because everything else is on the other side. I'm measuring something shorted in this area right here. Let me pull the board back out. We're going to measure the other side because that's where all the components are, the actual power supplies, the 3.3, 5 volt, the 1.8, the 1.2, all those different power rails. All right, so here's our 3 volt and our 5 volt. This is going to be the chipset, so it can be 1.05, and that should be 1.8, I believe. So let's get all those measured. I'm going to measure for a short first, because definitely the power rails aren't coming up because the main power rail is not on, so we can't get these power rails to come up. Oh, we have a short right here. All right, so we have a short on this power rail right here. Now, what does that power rail go to? I can't remember if it's a 3 volt or the 5 volt. One of these is the 3, one's the 5. You can see the discoloration here. I don't think that that is a symptom of it. This is going to be leftover flux that I just was when I was soldering on the other side of the board, because that's where we were soldering it. The flux got on that side of the board. Let's go ahead and do voltage injection. Let's get the thermal camera pulled up and see if we can see what is going to get hot or what's shorted out. All right, so to recap that we have, how many ohms do we have here? This is based on what we're going to inject in here. So we have 1.5 ohms. Wait, that's like a CPU short. But it's on the 3 volt or 5 volt power rail, so it's not probably not on going to the CPU. 1.5 ohms we can put right around 0.8 volts then to get enough current. All right, I have my Fluorowin Pro pulled up, so we're going to inject voltage right here. We can actually go up a little higher. So I'm injecting 0.8 volts, and it's only making a little bit of a noise, which means that we could probably go up to 1 volt. And we're getting closer to 1 amp. All right, now we're getting closer to 1 amp. Let's see if we see anything getting hot on this side of the board. Looks like you can see some reflections. You can see my ring light reflecting on there. It does look like something's getting hot right here. Wait, no, right here on the daughter board. Because that's not a reflection. So let's take a look at that, see if it goes away. Okay, see how it's cooling off? And then we take a look and see if it warms back up. Definitely is warming back up. So we are getting a lot of heat right here on the daughter board, on the other side of the daughter board. So the area that's actually heating up is right here. And this is where we're injecting voltage. And the daughter board's a separate card that we can actually replace. And it's the Wi-Fi card? The Wi-Fi card's right there. Let's take a look. Maybe it's just a cracked capacitor in this area, but is the Wi-Fi card shorted? I don't see a bad capacitor in this area. So does that mean we could just take this daughter board off and the short will be gone and the machine will turn on? I don't see any issue here. Let me measure for short in this area. No short there. No short there. No short. Okay, so I'm measuring short here. So is this shorted? Right here. Okay, we got the same ohms rating. So let's inject our voltage right here now. So I'm going to inject it right here and see what comes up. All right, because the card is metal, it's reflecting all the infrared or thermals. So it's hard to see, but it is getting hot when I plug that in right there. All right, I'm going to switch over to the P2 Pro and see if that will allow us to see this better without all the reflections. So what I don't like about the P2 Pro is a little bit washed out. It's hard to see, but we can actually see what's getting hot easier. It's more condensed. And so something right here is getting hot, right here. And that's exactly where we're injecting. I think it's going to be that chip because you can see the shape of it. Let me put some alcohol on this chip and see if that reveals itself. All right, so we'll drown it in alcohol. We'll inject voltage right here. And it is the chip getting hot. Now, a lot of times I've seen this, and it's not the chip that's actually bad, but I guess it could be. But what I want to do is I'm going to remove this daughter board. We do sell these, so we could just replace the daughter board itself. But if we can resolve the issue, for all I know, this is all mangled up and bent right here. But it's kind of strange that they would damage the motherboard, replace 2 different components, not tell the customer, and then now it's shorted over on the daughter board. So now let me check to see if the short is gone right here. Nope, we still have a short. It's a 5 ohm short. So we have some other short somewhere else. Magic. It's magic. So still shorted, even with this daughter board off of here. Now I want to measure to see if we have a short on the daughter board in that same area. And we definitely have a short right here. So we have multiple blown components. Hooray! All right, so what did they do to mess this board up? I don't know. So I'm going to pull the heatsink off because that's what they were doing. They were changing out the thermal paste, and when they decided to destroy this motherboard, now we're going to go down a rabbit hole apparently. Okay, I'm scared to see what looks like underneath this. Okay, looks all right. Thermal paste has definitely been changed out. It's moist. It's not anything fancy, but has definitely been changed out. All right, let's go back and inject a little more voltage again. We have the motherboard under the thermal camera. We're going to inject voltage again on this 3 volt or 5 volt power rail, whichever one it is. And we're going to see if we can find something getting hot. Don't see anything. What about over here? Do we have anything getting hot over here? So this is pulling about an amp at this point. What is taking that heat? What is taking the heat? Does anyone see it? Let me flip the board over. Are you kidding me? The CPU? Are you kidding me? Do you see that? Are you kidding me? The CPU is getting hot. So this is shorted through the CPU somehow. What did they do? What did they do? I think this repair shop's getting a repair bill. But right now it doesn't look like it's gonna be repairable. But is one of these MOSFETs shorted? Okay, so what's this measuring right here? 1.7. And the main power rail's right here. Got 1.7. So one of these MOSFETs are shorted? Interesting. I think we have multiple faults here. So one of these MOSFETs are shorted. Let's figure out which one it is. Now, because there's so many power stages here, it's hard to figure it out. But one of these is going to be shorted across, and we don't know which one. So if I measure from here to here, it's 0. From here to here, it's 1.7. So one of these is acting as almost like a wire sending straight through there. So we're going to go down to about 0.4, 0.3. We don't need much. We'll go back to our thermal camera, and I'm going to hold the ground on the back of one of these, and then we're going to hold the other side on this. Let's see if I can get it. Good contact. Okay, which one is it? It's down here at the end, it looks like. Okay, it's right there, right here somewhere. Right there. This one. So I think it's this one right here. All right, so here's our bad one. So let's get this removed. Now, why did it go bad? What did they do? They did something. So let me remove that and see what happens next. But that still doesn't make sense why injecting voltage over here is causing that issue. So it means we have also like our 3 volt or a 5 volt is actually shorted too. It's like they dropped a screw on this board or something. That's kind of what it seems like to me with the battery plugged in. They must have had the battery plugged in and they were doing all sorts of stuff. Let's go ahead and get this MOSFET removed and see if we can at least resolve that short, and then we'll continue testing. All right, I'm gonna preheat the board a little bit. Now, I'm not really super optimistic that this will actually fix all the issues in the board. It would be kind of nice if this one chip is shorted out in such a way where we have some pins messing up with the 3.3 and the 5 volt power rails or things like that. But it doesn't really make sense that we have so many different things bad, except that repair shop dropped a screw on the board or something like that. I don't know. And they obviously had something slip and rip some components off, or they had to replace those diodes, but I think that they just ripped those off the board on accident and had to solder them back on. If we remove this, it should resolve the short to the CPU, but we'll see if it resolves the shorts everywhere else. And actually on this model, I rarely see these MOSFETs going out because there's so many power stages on it, and most of the time these power stages do not go out because they don't have to work as hard. All right, it's almost there. Here we go. All right, and we have it off. All right, let's take a quick measurement here. The board is still hot, but I want to see what we're getting measured here now. All right, we're no longer having a short that is going all the way across there. I'm wondering if this other short has gone over here. Right here. Is this short gone? This short is still here. So we still have a short here. We have a short on the daughter board still, but we did resolve the short there on the CPU. And there was this is, I think, tied to that one. So let's see if that short's gone. Yeah, so this short is gone now. I bet they dropped something over here. I mean, again, what are they doing? Did they have the battery plugged in at the same time? Let's see if we have a short on our EC chip anywhere around here. None of this seems shorted anymore. All right, so let's see if we can figure out where the short is now for the 3 volt or 5 volt. I can never remember which one's which, but it's gonna be one of those two. The problem is because now that well, two things. The board's hot, so it's gonna be harder to do it with thermal camera. And the other thing is that we got 6.6 ohms. That's pretty high. So injecting voltage here, we would have to inject quite a bit of voltage or current in order to get anything to heat up substantially. Because earlier we injected it there and it was heating up on the daughter board. We took the daughter board off and then it's still shorted here, but it's not shorted as low as it was before. Maybe we'll just measure around a little bit more and see if we can find a short somewhere else. So let me measure these guys. There's a short here. That's clear, that's clear. Okay, let me check the chipset, make sure we don't have a short on the chipset. We have okay, 28 ohms, that's okay. 29 ohms. We just don't want anything close to 3 or 5 ohms. That would be the worst. So 30 ohms is fine for a chipset. Like we measure here, we should have about that too, because that is the power supply for the chipset. That's good. That's fine, that's fine. I don't see any other damage anywhere. This is just heatsink compound. I don't know why it's still on the board, but maybe this is actually more like the pads for these chips. Yeah, they are. It's the pads. They're all just dried and flaky. All right, we will have to do voltage injection again, see what we can do. Okay, so the board is still hot, which makes it so you can see the outline, but we're probably not gonna be able to see what's getting hot when we're doing voltage injection, but we'll do our best. And I just wanna make sure that we're not getting a hot CPU or GPU, and then we can actually go up to a higher voltage once we know we're safe there. Start out with 1 volt, and we're really not getting any current draw at all. So now we can go up to, I'm gonna go up to 2 volts. Let's go up to 2.5 volts. It's pretty high. But the reason why I'm having to do that is because we have such high resistance at 6.6 ohms. And the board's pretty hot. Let me see if I can blow this off. Wait, did I see something here in the middle? I do, right here in the middle. Got 2 things, one here and one thing over there. But the one thing in the middle, it's another MOSFET that goes to the CPU. So it's not one of the main ones. So the question is, should we take that off? Probably. Let me go ahead and get that one removed and then we can continue. So this is the one that's heating up. And what is the chip number on that one? It's gonna be a little bit different than the other one. The other part number, I believe. Maybe the same part number. This is an 81210. Yeah, and these are 302045s. So a totally different chip. Let me pull this one off. What did they do? How could they have blown out so many different components that are CPU related? All right, preheat it, add some flux. All right, well, we got that one off. All right, with that chip off of there, is the short gone. And it's at 37 ohms now, so we're getting higher up. Now, right now the board's hot, so we're gonna let it cool off. Let me actually blow it with my blower to cool it off a little bit. And then we'll come back and measure. Whenever components are hot, they're actually gonna measure a lower resistance, so we have to cool the board off. 32, 33 ohms, still pretty low. All right, let me show you what our donor board is. Let's see what it measures at. Should be a lot higher than that. So, we're measuring nothing. Here, let me just put it in straight resistance mode. And it's in the kilo ohms. The kilo ohms. So we still have something shorted to this power rail. That's bringing it down to 32 ohms, which is excessively low. And so now we're in the range where we can't inject any voltage at all because 32 ohms is not going to be, it's going to be too high. I wonder if we can actually plug in the power. Let me replace these two components. We'll plug in the charger and something will probably get hot and show us what the issue is at that point. That's really what we're going to have to do next. So let me get these replaced using our donor board here. All right, so I'm going to remove this one and this one, just these two. And then that way we can get those transferred over. And we're going to verify it's the same chip number, right? 81210. 81210, perfect. And then the other one was a 302045. 302045, perfect. All right, let's get these removed. Okay, one chip out of the way. Two chips, perfect. And I'll start with the 81210. All right, I got that one soldered on. Let's get the other one installed while we're at it, while the board's still hot. And this one goes on this direction. And tack that in place. Let's put some more flux on here. Okay, that was good. I just need to touch this up too. All right, looking good. All right, so now that we have those two components replaced, we're gonna have to let the board cool off first, but I wanna plug it in and see if any of these other power rails are warming up and see if we can figure out what's causing that one power rail to have still have a short on it that's kind of high. But let me let this board cool off and I'll be right back. All right, I'm just gonna boot it right here on the desk. There is a power button on the back here that I could press if I need to, but I think when we just plug it in, we should be able to see something heat up. So let's get under the thermal camera. All right, you can see it's a little warm still, but I'm going to press the power or plug in the power in 3, 2, 1. Okay, I saw something heat up. Let's put the power meter up, current meter. All right, plug it in. I think I saw something right here. Oh, okay. So we have this chip's now hot, which is what controls all of these. All right, so we replaced two of these. We have to replace that now. How did it get so bad? But let's measure these power rails. I want to see if they are coming on. It'd be kind of interesting if they are. So I am measuring on the one that's shorted. And we're getting 5 volts there. So that's now coming on. That's the 5 volt. And this one, we're getting 3.4 volts. But we are pulling 0.06 because of this chip right here getting hot. Let's see if we can see anything else getting hot. And actually, can I press the power button? Let me press the power button and see what it does. Nothing's happening. We can see the LDO's on. That's what this chip is here. This is the EC chip that's on right there. So when I pressed the power button just now, it went down to that 0.03, which is what it was doing before. and then it's back off. Let me plug this back in. Yeah, we're gonna change that out. Let's do it. I think we're gonna end up changing out a lot of stuff. So we've already changed out 5 chips. We're on our 6th one. How many chips do we change out before we call it? So this is the PWM controller for all the power stages for the CPU. Now it's not unheard of to have to replace this if we do have VRMs burned out, but the thing is, how did this happen? When you just take it to a repair shop to change out the thermal paste. This thing doesn't have liquid metal on it. It wasn't shipped with liquid metal, so it wasn't something like that. They had to have had the battery plugged in and they dropped a screw on the board or something. So this is an 81266. Okay, there it is. Set it over there with the rest of our chips. And so we'll grab this one off of this board. All right, this is going to be our new one. Now before I install it, I actually want to see if the short is gone over here. And the short is gone. So this was shorted to this component and to this component over here. Or maybe it was only shorted to this one and it was going through here to this one. Or maybe, I don't know, a combination. But the short is gone with that off of there. So now when we reinstall this, hopefully the short will be gone completely. All right, tack it in place, add some flux. All right, that is replaced. Now, did we resolve the issue? Low likelihood. I think we're getting down to the 5% chance that this is going to be fixed because of all this damage. Because the odds are that if we damage major components like this, we damage minor components, and minor components are going to be a pull-up resistor or something like that that we're not going to be able to find, or the CPU itself. Okay, before we turn it on, let's measure over here again. Our short is gone. Okay, here we go. Let's see if it's going to work. So I'm going to go into voltage mode. Let's go thermal camera. That way we can see it heat up, if we do have anything heat up at least. Plug in the power. 0.07 again, 0.09, 0.05, 0.03. As long as it rests down close to 0.02, then I'll be okay. We have our 5-volt power rail. We have our 3.4. This one should not be up yet. That's going to be the chipset. That happens when we turn it on. This is the 1.8. That's not on yet. We should have 20 volts over here. And then this is our charge circuit. And that doesn't have anything on it because we don't have a battery on it. Okay, so we are resting at 0.02. So let me flip it over. We're going to press this power button right here. And I want you to pay attention to the power meter. If it's going to come on, this is the moment of truth right here. 3, 2, 1. 0.04. And we're not moving. So we have something else wrong. I think our EC chip's probably burned out, or, well, the EC chip is listening, so it can't be the EC chip. We still are not triggering something on. Let's see if our chipset power rail is coming on. Chipset power rail is on. Let's see if our 1.8's on. 1.8 is on. Let's see if this one's our VRAM memory power supply. That one's not coming on yet. So the CPU did not trigger on. But we do have voltage all the way through here. Even the BIOS has power. So we have voltage now. When we press the power button, we have our 3.3, our 5 volt, our 1.8, and our 1.0 for our chipset. And we have also the BIOS chip is energizing. The chipset's coming on. Actually, let's measure all the way around the chipset. We're going to measure all the rails on the chipset. Press it. 0.04. So I'm just going to measure all these caps here because there's a few different power rails that actually go into the chipset here. So we had our 1.8, here's a 3.4, 3.4, that one's missing, 3.4, 3.4, 3.4, 3.4, okay. I'm just gonna skip around here a little bit. 1.0, 1.0, 1.0. All right, so that's actually looking good. I mean, the only one that looks weird is this one. It says 0.04. So let's measure the ohms rating on that 0.04 and see if we have a short here. 70 ohms, that's not bad. So we're doing okay with that. You know, so at this point we have something that's probably catastrophically damaged the laptop, the chipset or the CPU. Let's actually measure the ohms on the CPU. I think it's not too bad. 1.2, that's pretty low. Pretty low. What CPU do we have? SRK3Y. Here's another SRK. No, this is a SRH80. Let's see what ohms rating this one is. 1.83. Now the higher end the GPU is, or if it's like an i9, it's gonna have a lower resistance. And if it's like an i5, it will have higher resistance, or an i3. All right, let's go around and do a little bit more physical inspection. Oh, I actually want to see if it charges the battery. That's the other thing I'm going to do. Here's another thing I just noticed. They had broken this latch here for the touchpad. Like you can see one of the sides is broken off, the other side isn't broken off. I mean, it's fine, we can just put it in there, but they even broke that. I'm going to try to get it back in there. There we go, okay. I'm going to put a piece of tape on it so it doesn't fall out. Okay, all right, let's plug in the battery. All right, I got the battery plugged in. Keep an eye on the power meter, let's see. 0.11. We want to see if it jumps up to 0.2 and then starts charging. 0.23. It's going to start charging the battery. It's thinking about it. 0.23. There we go, 2 amps. So we are now charging the battery. We're a step closer, but the board's still not turning on. Or is it? Let's see if I press the power button, if the current will drop down when I press the power button. I did not listen to my key press. Interesting. And if we look under the thermal camera, we can see that the charge circuit over here should be getting warm, which is what we changed out. We replaced both of those and we replaced the power management chip. Now we should have our 5 volts over here now, right? On our VDD. So we'll have 20 volts here, 5 volts there, and we should have 3.7 down here. I think it's 3.3 there. I don't know, this one's kind of stumping me, but I mean, I'm not surprised at this point. So I think we're gonna have to kind of look around a little bit more and see if we identify anything else that's ripped off the board. There has to be something else that we're missing here. Or it's gonna be a chipset that's completely burned up or something. Got some thermal paste there. Ah, we see it. We see it. Oh, we know what happened now. All right, do you see the evidence? Okay, so if we use our rules of deduction here, or trying to figure out exactly what has caused this or how a repair shop could have destroyed this, right here, you see all that burn mark? This is the DC jack. This is where the input voltage comes in. And we have a arcing going on here. We even have some solder melted on this pin. Now this is probably, I think this is the 19 volt side. Let's see. Yeah, so this is the 19 volt or 20 volt side. And then the next part should be ground, I believe. Let's see. I can't really see very well because of all the arcing that went on. I think that's ground, ground, ground. All right, so, well, if they just arced across the ground, that can't damage anything. Now, there's going to be the PSID pin, which is the charge detect. So we have these lines are all the positives, these are all the negatives, and then this right here is the PSID pin, which comes to right here. And that's going to tie somewhere on the board, I can't remember. But we don't see any damage there. This is just for me soldering on the other side of the board. So they definitely shorted something here. Now, whether it was them measuring, trying to fix it later, I don't know. I don't know what all this, it almost looks like hot glue. Almost looks like hot glue on this. But we are charging the battery now. We're just not turning on. And did I try turning it on with the battery plugged in now? I don't know if I did that or not. Can't remember. Oh yeah, I did. Well, here's battery only plugged in. Battery only, still not coming on. Well, I'm kind of at a loss at this point, but the fact that we have all the power rails coming up now, but the machine's still not coming on, we press the power button, the EC chip is telling the boards to turn on the chipset, so it's turning on the chipset power supply, it's turning on the 1.8, and the BIOS chip is getting power, but at that point the machine's not booting. I'm gonna move on to a BIOS at this point because that's really the next step. If I had this board show up in front of me and it was doing this exact symptom, that would be my next step. I don't know if the odds are very high that that would happen, but if there was some sort of power surge on the 3.3 volt line or data line, and it could have surged the BIOS chip and caused it to corrupt. So let's go ahead and write a new BIOS on here. All right, let's figure out what chip we have. We have a 25R127D. And so here's our chip reader. It's just a little Poco pen reader. And pen one's here, pen one's there. Okay, so we're gonna set it across here like this. Okay, we need to detect the chip, make sure it is showing up properly. Okay, we have it showing up. And it's a 25R127D SOP, there it is. Let's read the contents. We always wanna back up the contents at a time. That way we can always go back to it if we need to. All right, successful read. Let's verify that. So we're just gonna read it again, and we're gonna verify that's the same thing that's in the buffer. Let me try this again. Sometimes if you don't hold it just right, it doesn't get a good clean read. Okay, good. All right, so let me save this off. All right, great. Now that I have that saved, let me see if I can find a BIOS that I already have made. All right, I do already have one already made, so I'm going to load that into the buffer, and then we will write it back to the chip. Okay, so that wrote successfully, and so we will know within a moment whether it was a BIOS issue or not. Okay, so plug in the power, got 0.01, 0.09, then 0.03. So it's resting at the 0.03. Should be 0.02, but I'm okay with that. Press the power. And still not doing anything. Do we have all of our power rails? Okay, we don't have our power rails. Hold on. Here we go, we got 5 volts, 3.3. And our 1 volt's not going to be there until we press the power button, so I press the power button. Okay. And then now what? And now it's shutting off. Okay. Okay, new day and a new fresh set of eyes. So I spent more than 2 hours yesterday working on this thing and basically gave up. I've already replaced, what, 5 chips or so, but we do have it actually kind of making progress, right? It's charging the battery now. The power rails are all coming up. We tried flashing the BIOS. That did not resolve any of the issues, but I just want to give it one more last-ditch effort before we give up on this. I hate failing when it comes to repairing something, especially if we're making progress. And so at this point, we need to just kind of continue examining the board now that I did get some sleep and ate some breakfast, and I'm ready to go. All right, so let me plug in the charger again. Let's look at the power meter. I just kind of want to reacquaint myself with what's going on. So plug it in, 0.06, and it goes down to 0.03. I'm going to measure the power rails, and we have our 5 volt and our 3.3 is present, and then our main power rail is present. And then this is going to be our chipset, and that one's not present yet, and the 1.8 is not present. Let me try to trigger it on. Again, I just want to make sure that all this is working. And so it's not pulling any current. When I press the power button, it goes up to 0.04, but it does go up a little bit from 0.03. And our 5 volt's still there. Let's see, 3.4, and then do we have our chipset? Our chipset's there. And our 1.8 is there. Perfect. All right, so the board's attempting to come on, but CPU and GPU are not triggering. And so the issue with this is, I can spend another 5 hours on this, I've already spent more than 2 hours trying to chase down different chips that are blown out or whatever, and it could be some sort of passive component that's very hard to identify. Sometimes you just need to step away from a repair for a little while, think about it, and then come back to it. So I want to get back under the thermal camera, just take a quick look around again, and see if we see anything that is looking suspicious or not. That's how we have been identifying anything. Right now we do have the board trying to turn on, but do we see anything that is lighting up a little bit suspiciously? So here's what I want to pay attention to. You know, so we see all these heat spots here. We have a heat signature here. That's going to be our LDO that's on, linear voltage regulator. That's powering the EC chip, which is on right here. You can see that it's getting warm. And then what else is warm over here? We have this chip right here that's getting warm. So that's on. And anything else on this side? We see something right here. It almost looks like a capacitor or something. Is it this area? Yeah, so right here, we have something getting warm. Let me see if I can identify what it is. Is it this capacitor? Nope. Is it this chip right next to it? It's a resistor getting warm right here. Well, that's interesting. Let's zoom in on that spot. All right, let's measure the voltage in this area. And we're getting 0.01 volts. What about this side? Nothing. What about over here? Nothing. Nothing. I don't know what this chip goes to or what it's trying to power. We got 0.1 here. That doesn't seem like enough volts. Let me unplug this and let's go to ohms mode and let's measure the resistance in this area here. So that's fine. It's measuring 22 ohms. That's fine. It's fine. We got 1 ohm here and 0.1 here. Okay, all right. So we have, it looks like a short in this area because this is only 1 ohm. What about here? 22 ohms, 22 ohms. I can see a mark on this resistor. I think it's from me just kind of scraping across. I don't think that's an actual crack or anything. Resistors don't generally crack, but yeah, that's just for me trying to measure on there. What about right here? So that's 22 ohms, and that's nothing. Okay, we got 1 ohm here again. All right, so what is this tying to? We're gonna do another round of voltage injection apparently, because there is so many shorts in this board, so much damage, and of course, we're gonna find one other short that we get to inject voltage on. All right, so we were at 1 ohm. 1 ohm of resistance is pretty low, so we can actually put that right around 0.6. Unfortunately, the more items I find shorted out, I feel the less likely we're gonna be able to fix this. So we're gonna inject it right around here. Let's get under the thermal camera. Oh, it looks like it's the chip. So I'm injecting right on that capacitor, and then right next to it is what I'm seeing getting hot. Yeah, so it looks like this chip might be damaged. The capacitor that's tied to that chip, I'm injecting right there and it's heating up the chip, so most likely that component is actually shorted out. So let me just get that chip replaced. We're just kind of working our way through this. Now, if it doesn't fix it, then what else is shorted? I don't know. We can take it off of there and see if the short goes away also. This thing is really on here. It's taking a little while to heat it up. All right, so we have this chip removed. Again, I don't even know what power rail it goes to or what it goes to at all. And I don't need to know, luckily, because we have a donor board. Let's see if the short's gone. The short is gone. What about over here? We still have 11 ohms over here, which was 22, which is probably fine. Let me grab a donor chip and get that installed on there and see if that resolves that issue. I'm gonna put some fresh solder on here though. This chip, my donor board's laid out a little bit differently. I think this is it. See, this is PUW1. This looks, I think these go to the CPU, actually. Let's see, P9529P. P9529P. Yep, so same chip. So here's the component we're gonna be taking off. It's gonna be right over here. Yeah, so I think all these PUWs actually tied to the CPU. So this is all part of that CPU circuit that we've been having to replace quite a few components. Now, why did the the CPU fail, or why did that MOSFET, the MOSFET PWM controller fail and this component fail all at the same time? The daughter board still is shorted out. Remember, after we get all this fixed, the daughter board's still shorted, but luckily we can just change that out if we need to with a new one. All right, that's gonna go like that. Okay. All right, we got that taken care of. Now that we found, what, our 6th or 7th chip, is this shorted? The short is gone over here. We still have 12 ohms in this area, which I'm not super concerned with. And all this stuff is looking good. Let me clean it up just a little bit more. Okay, let's see if we're making progress. Okay, we've got our power meter up. Plug in the power. 0.07 and then 0.03. And then now we can hit that power button. And we got nothing happening. So it's not even jumping up to 0.04. Oh, there it is. It jumped up to 0.04. So same symptom. Is that what we got? Now we're up to 0.05. Are we making progress? Here, let's go down to the thermal camera. Here, let me make sure that all these other power rails are coming back up still. So we still have our 1 volt there and a 1.8 and our 3.3, 0.05, huh? What's the thermal camera say? Now the board is kind of hot, so it's kind of hard to see anything here. All right, so we have the heat here for our EC chip is on. And what else we have? See anything standing out? All right, I'm gonna let this board cool off so then we can see if we can identify anything else shorted. But we may just need to start poking around and see if we can find any other shorted components because, you know, we were lucky and we found it with the thermal camera, but I mean, there's probably something else shorted that's not even coming on. All right, now with the board cooled down, let's plug it back in. Let's see what else is getting hot. And we do get a spike over here, which is the power management chip. I see the LDO is on, and then I see this is the EC chip, but what is this right here? That's what I want to figure out. Right here, this chip. So this area right here, these are going to be the MOSFETs that produce the 1 volt power rail for the PCH. I'm not actually sure what PUH1 is, but let's measure some voltages in this area. So let's see, we got 5.2, 5.1 volts here, 0 there, we got 4.7, it's kind of a strange value, 4.7, 4.7, okay. 4.7 seems like a weird value. Usually you'll have weird values like that if it's like on the battery charge circuit or something like that, but this is all PCH stuff, so the chipset should be right around 1 volt or 3 volts, 3.3 if it's using any of that. So I don't see anything else on any of these other lines. Let's go ahead and trigger the board on and see if it changes. Let's keep an eye. So it's still bright, so that's still hot. And then I'm going to press the power button, see if it changes. And it dimmed. Okay. Let's see if anything changed here. Okay, now we're at 6.2 volts. We were 4.7, so that went up. This is 5 volts here. Definitely some strange values in this area. Now, whether we're supposed to have that or not, I don't know. We can grab a test board. Actually, that's a good idea. Let's grab a test board and see what voltages we're supposed to have there. All right, so this board works. It powers on, but it has no display. So there's some sort of issue with the display circuit. And so let's look at what this one looks like when we plug it in. So power's plugged into it. And I'm not seeing any current on this. Let me make sure I have the DC jack plugged in all the way. There we go. Oh, this one must have a short somewhere because look at that. When I plug it in, it gets really hot in this area. So that's the LDO that got really hot, and then this other chip over here got really hot. This is a no bueno test board. Okay, here's another one of these that has a LCD not detected. All right, let's plug it in again and see how it's supposed to light up. Okay, 0.02, and then look, we're not getting any spiking of heat anywhere. So on our board, we're getting a spike of heat over here. I could see it warming up right here. This is gonna be the LDO, this is the EC chip, but we're not getting that PCH chip or PCH area hot. Let's take a look. Let's see what voltages we're supposed to have in this area. So 5 volts, 5.1 is what we had right here. 4.7, okay. So that matches. So all that looks good. Now let's power it on and see what it does. See what voltages we go to. 6.2, so that's all matching actually. Very interesting. Now you can see the boot sequence on that. It took a little while for it to start heating up, or actually start pulling some current. We'll do it again. I want to show you what it's supposed to do when we turn on and press the power button on these boards. So here's the power button. Get ready. So I'm going to press it. 3, 2, 1. So it's at 0.02, 0.58. It goes back down to 0, and then it should come back on at like 1 amp or something like that. Yeah, 1.72. So that's the triggering on step. Now I want to measure this line while we're doing that. So plug in the power, 4.7. I'm going to press the power button. So right as I press the power button, it goes to 6.2 when it does that first initial jump. Okay, what else are we missing here? We might as well get some other voltages while we're on this board, because our board's still acting a little weird, and I don't know why this chip's getting hot. So maybe there's an output on this chip that's getting hot for a reason. So again, if I plug in the power on our test board, the only thing we're getting warm is going to be our LDO and our EC chip. And then this other chip kind of pulsed on for a second, and that's it, right? So now let's go back to the customer's board. Okay, here we go, 3, 2, 1. So that got hot a lot. So that's our power management chip, which we replaced that over here already. We replaced the power management chip first with a brand new one. So that's actually having an issue right as it powers on. Whoa, okay. And then that other chip over here is hot at the same time. Let me reflow that power management chip and see if that changes anything. Maybe I have a solder ball under there. But it is charging the battery, so all the power rails are coming up. I have a hard time believing that this is an issue unless one of the lines are tied to something that's shorted. We can measure around that chip actually before we do that. All right, nothing's showing up shorted here. So yeah, let me reflow that real quick. Because remember, they had damaged these two components right here. And I was assuming that these things blow out all the time. That's why I went straight and replaced those. I'm trying to get off whatever this is. Okay, I just went ahead and just reflowed that chip. Now that's a brand new chip, so we shouldn't have an issue with it unless we replaced it preemptively before all the other stuff was replaced and it ended up damaging it. So we may end up switching back to another one just to be, you know, cover all of our bases. The fact that it does spike could mean that it's just trying to power something and it gets warm and it shuts itself back off, something like that. But we're gonna need to see what it's powering. So every time we plug it in, this gets hot over here. So, well, this right here. And so does it mean that this chip's bad? Do we need to change that one out? Because if this spikes when it's trying to light that one up or start that one up, then, you know, because the thing is a lot of times when you have a chip that's hot, it doesn't mean that the chip is bad, it's what it's trying to power. So we got to get that in our head, that the odds that it's the actual chip that's bad is kind of low. Everything's going to be hot, but we're going to see if it spikes again. Still spiked, and then that still got hot there. Let's change this guy out just because it's right here. But we need to protect all these components. Great, it's right next to all this stuff here. It's gonna be hard to avoid messing with this. This is the touchpad connector. This one's not even used, it's only when you're on the 17-inch model, but this machine is the 15-inch and uses this one. This is the 17, this is the 15-inch, yeah. So it uses this connector. That's why I put a piece of tape on it, because these latches like to break. I'm gonna have to see how we can protect that without damaging it. I'd rather not have to replace this part, actually. Before I do that, let's just plug in the power. Let's flip over the board. Let's plug in the power and see if we see any other spikes of anything. Was that something right there? Flip it around. There's so many hot spots. It's hard to read it. Okay, I got the board a little cooler. Let's try it again. Okay, saw a spike right around this area. Is that staying hot right there? What is that? No, I don't see anything. So there's definitely nothing as obvious as that other chip over there near the PCH. Yeah, I don't know. I'm thinking that we're gonna have to change that one out because right as we plug it in, we get that spike here, and then that heats up. Yeah, let's pull that guy off. We're gonna have to put a lot of Kapton tape over here. I'll put some copper tape, some aluminum tape, put all this stuff over all these connectors to try to protect them as best we can. We're gonna blow the air away. So we'll blow in this orientation like this, try to blow across. You preheat the board like this, and then you'll come in and grab the chip. That's kind of the plan. All right, so I'm gonna put all this really thick Kapton tape over this whole area. I'm actually gonna do 2 layers. I definitely do not want to damage that connector. And then I'll add a piece of this copper tape. Okay, good to go. All right, so like I said, we're gonna have to heat this area first, and then we'll come in and grab that. Try to be as careful as we can. So I'm gonna heat here as long as I can. Once we start seeing stuff melting over here, then we can just go over there and grab that. Okay, let's grab our donor. Make sure this is the same chip. Yep. All right, this latch is already busted, so I'm just gonna not worry about protecting any of that stuff. I already got that one off of there. Let's get this one installed. All right, there we go. Hopefully we protected those connectors good enough. There was a lot of heat in this area. But we're basically at the end of the road at this point. I've already replaced so many different chips, and we're just kind of chasing our tails, and I could spend hours and hours and hours, which I've already done. I've already spent, looks like 3 hours on this. And it's all because a technician damaged the board but didn't tell the customer, right? I'm hoping that I'm making progress. Let's see how these connectors turned out. Connectors look good. All right. Let's plug in the board. Let's see what it does. The board's hot, so we're not gonna be able to see it very well under the thermal camera, but let's just see if this area spikes over here again. It did not look like it spiked, actually. All right, does that mean that we're good? Let's see, press the power button. Don't see anything different. Or does that mean the board's still hot? Let me cool this off. All right, I cooled the board off. Let's see if that makes a little bit of a difference. Plug in the power. It looks way better. We're not getting that huge spike there. That chip's not hot anymore. Okay, so I feel like we're making progress. Okay, well, it looks like we're making a little bit of progress, but it's like 1 step forward, 2 steps back. So anyway, I mean, we're just chasing our tail at this point. We obviously can see that we have component after component after component. So it was a cascading effect of damage that was put on this motherboard by that technician who worked on it. And so I'm definitely going to recommend having the repair shop pay for this repair because these boards are expensive. I think this board's probably $500 or $600 at least. And I'd love to know your thoughts on this one, and thanks for watching. I couldn't save this laptop.